I'd like to discuss invertebrates today and an introduction to symmetry and thinking about those organisms. What is an invertebrate? So the definition of an invertebrate is that it doesn't have a backbone or a spine. So that actually is kind of an overarching term that includes all organisms except those that belong to the vertebrata, which is a subphylum of the phylum Chordata. So when we think about invertebrates, we want to start to describe those organisms or those specimens or those fossils that we find in our backyard and try to deduce how that organism lived. And so invertebrates can be wildly intricate or they can be fairly simple if I'm not being too I don't want to insult those invertebrates being too simple, but so we want to start to deduce the type of environment that those organisms lived and how they lived actually. And we can get a lot of information from just a simple little fossil and considering the symmetry of it, and we can start to think about how it moved. So let's discuss symmetry for just a moment here. So the first thing you might notice about a specimen that you pick up or a dead organism that you find or a fossil is the general shape. And so one of the descriptors of that shape is symmetry. And so what symmetry is a recognition of some type of organized structure that maybe can be reflected, where different sides of the organism are the same. For example, a human, you can tell if you split it down the middle, the right and the left half are the same. And so that's a type of symmetry. And so the first type of symmetry is the lack of symmetry. For example, a shell. The general overall shape is asymmetrical. So you want to look at it on all sides and consider it. And I come up with the fact that yes, it's very organized in its structure. It has this spiral shape, but the overall shape is asymmetrical. I can't find a mirror plane here where two or more sides are the same. So that's asymmetry, the lack of symmetry. Another type of symmetry is called radial symmetry. And that's where the tight definition of radial symmetry is where you almost have an infinite number of mirror planes. You could cut that organism in any direction and those pieces will be the same. So if you think of a pizza, right? If you cut that pizza down the middle, across the other middle, across the side, all the pieces look the same. You can turn it around. You can fold it in half and all those folds are going to be represented equally on both sides. So a more specific form of radial symmetry is called pentameral symmetry. So pent or penta, that refers to the number 5. And so pentameral symmetry, for example, is a type of radial symmetry where there are 5 equal pieces. And so if I'm counting the pieces on this specimen, and actually the back kind of gives it away, you can actually count 5 areas that are the exact same as the one that's next to them, or mostly. So if you can look at a crinoid, for example, we'll talk about those eventually, or an echinoderm here, you might say, hey, I noticed 5 structures on here. And it's not only just the markings, but you could start to split this organism into 5 equal pieces, and that's pentamerally, radially symmetrical organism. So pentameral symmetry. So the last type of symmetry, we would say as humans the most sophisticated type of symmetry is bilaterally symmetrical organisms. And so bi is 2, and so bilaterally symmetrical organisms have a plane in some direction that you can cut it where those 2 halves are mirror images of each other. So again, I said humans. If you cut them down the center here, kind of sagittally down the middle, the 2 right and left sides should be mirror images. So a more ancient organism is this ammonoid here, and maybe on the top here, on one plane that you would consider, it doesn't look symmetrical. It looks, again, this spiral shape, but if you turn it all around and you look at it kind of head on, you can see, oh, actually, the right and left sides, you could take those pieces apart and they would look the same. They would be symmetrical. So I can identify two sides, and that's bilateral symmetry. Another example is the cephalopod. It's a squid or a cuttlefish. And again, if you kind of look at it from the top, the tentacles look radially symmetrical. So the soft parts are radially symmetrical. Maybe it has maybe 6. I should count them, but 6 or 10 or all those scary tentacles, and they're radially symmetrical around the mouth. But if you look at the hard parts, I could actually cut this organism, down the center in this case, and find that those 2 sides are the same. And so again, that's bilaterally symmetrical. Lastly, I wanted to show you this one because you'll be seeing it over and over. It's an important fossil. This is a brachiopod. And the tricky thing about brachiopods is basically it has two shells, so it's a bivalve, and you would think that, well, that top and bottom should be the same, shouldn't they? You should have this plane across the center where those two shells meet, the plane of commissure. But actually with brachiopods, that's not the case. If you can see, it actually kind of has this wave motion if you look at it head on at that plane of commissure where those two shells meet. And so, but if you think a little bit differently and try to cut it a different way, actually, if you go down the center, perpendicular to the plane of commissure, we see that the right and left sides are the same. So that is another bilaterally symmetrical organism. It's a little tricky.